How's it going? So this video is being done by request. It's the 2007 AIME II Problem number 7. I did want to mention I did add 2 more channels to my featured channels list on my channel, and those are of the puzzler. He does kind of like puzzle math problems. It's logical thinking. It's a pretty interesting site. It's doing pretty well, pretty interesting channel. You might want to give it a check out. Just go to the featured channels list. I think it'll be like over here somewhere. And then click that one. The other one is Sohail Rathi, but I'm not sure if I'm pronouncing that correctly. Sorry if I'm not. He's a pretty famous AOPSer. He's middle school, I believe, but he made a site called Omega Learn. And it's basically a really cool resource that taps you into all kinds of free resources that you can use to prepare for various competitions, not just AMC. So check out his channel. You can leave him a comment and ask him where his website is. Maybe I'll link it in the description. In fact, I probably will. Just check those out when you get time. So here we go. This is the 2007 AIME II Problem number 7. We're going to be doing it in kind of 2 different ways. The first way is what I call brute force. What's brute force? Brute force is you don't know what you're doing, but you're going to get it right because you don't care and you have to get it right and you refuse to skip it. One thing you want to remember is that on the AIME, again, there's only 15 questions and you have 3 hours. That's an average of 12 minutes per question. You're not really in a rush. Brute force? I'll take my points, right? That's 10 points, getting you 1 step closer to your USAMO qualification. Now the math purist is going to look down and say, oh, you didn't do it the proper mathematical way. But you don't really care because you got a USAMO qualification, right? So that's kind of how you have to think about that. Sometimes you're not going to be able to come up with the most beautiful solution process possible. And I just want to say that's fine. It's much better than skipping and giving up, right? You found a way to overcome. And we're going to look at that solution method as well. So then afterwards we'll look at the more appropriate kind of pure, beautiful math method, right? Where you're the master of your domain and you could answer it no problem. We'll get to that solution too. So for starters, let's get going. Given a real number x, let this, which is the greatest integer, less than or equal to x. It's also more commonly called the floor function, and it basically just means round down. Denote the greatest integer less than or equal to x. So again, if you had something like 1.4, that would round down to 1. Right? That's all it is. You're rounding down. But you don't have to go below 1. So the greatest integer less than or equal to 1 would also be 1. Right? Okay. So now that we understand that, I don't want it on my board. We're going to need all the space we can get. For a certain integer k, there are exactly 70 positive integers. This is important. Exactly 70. Not 71, not 69. That's going to be a huge help to us late in this problem. We'll see how. Positive integers starting at n1, n sub 2, all the way to n sub 70. Such that k, again, this is a certain integer, not just any, can't just be multiple integers, it's one integer that does this, a certain one, okay? K is going to equal the cube root of this first number rounded down would need to equal k. Interesting, but it's also going to be the cube root of n sub 2 rounded down all the way to, of course, they're going to stop when they get to 70. We take the cube root of all those numbers rounded down is going to equal k. And k needs to divide n sub I. Okay, so n sub I, don't get confused, for all I such that I is between 1 and 70 inclusive. In other words, it's n1 to n70, right? So k needs to divide every one of these numbers. Another way to say that is each of these numbers inside the cube root is a multiple of k. That's a lot to take in. And then finally find the maximum value of this. Man, don't even try to think about that right now, right? Your brain's probably kind of frying a little bit. You need to just kind of break off pieces that you can understand. So what I want to do, again, this is kind of the brute force start, but we can also use the brute force start to transition into the beautiful method, and we'll talk about that. So first off, let's just kind of think about this. If I'm cube rooting a number and I round it down and it needs to be this, then it's kind of like, let's just give it a number. Let's try 10 cubed, right? What are we saying here? If we use 10 cubed and we cube rooted that value, of course you're going to get 10. Okay, but what if we made this 10 then equal to k? Just kind of try out, see what happens, right? A lot of times when you don't know what you're doing, explore a little bit. Just see what you can learn. Especially on the AIME, you want to kind of learn what's going on in the problem. It's not that you're going to know instantly what is going to happen. This is also true for AMC questions. You'll hear me talk about it a lot. So let's say that k was equal to 10. Now we would make this n sub 1, sorry about the rocking board, it is what it is. Make this n sub 1 basically 10 cubed, which is 1,000. Okay, so then yes, when I round down, right, when I round this down, it will still equal 10. Okay, but then this number needs to be a multiple of this. Well, I guess, you know, a multiple of k. So if this is 1,000, maybe this one could be 1,010 inside of a cube root and rounded down. If we check that out, the cube root of 1,010 rounded down, yeah, it's kind of logical. It's going to equal 10 as well. The question is, can I fit 70 of these multiples in between? So if the first one is, well, if that's 10 cubed and k is 10, what would I need? I would need 1,000 plus, and the next one's going to be, right, it's going to be 1,010. This is your second n value. And then the next one would be 1,020. And I need this to go on such that there's exactly 70 that do this. Well, again, we could probably check what 11 cubed is. Because what we can't do is go over 11 cubed. If we did, when we rounded down, it would become 11. So let's just check. If we look at 10 cubed, right, that's 1,000. And 11 cubed is 1331. I don't know why I remember that. Maybe because it's part of Pascal's, is it? No, 1331? I don't know. I think it's part of Pascal's triangle. Yeah, it is, right? 1, 2, 1, 1, 3, 2. Yeah, right. 1, 3. Come on. Everybody knows that. All right, yeah, so Pascal's triangle, 11 cubed. You might not know it. The top few rows of Pascal's triangle, I think up until 11 to the 4th are all multiples of 11. So after that, 1, 4, 6, 4, 1 is 11 to the 4th, I believe. But after that, it breaks down. Anyhow, look into that later. It's kind of interesting. But, so 11 cubed, that's what that is. The question is, if I take 1,000 and I add the next 69 multiples of 10, why not 70? Because we already have one in the first part, right? 1,000 itself is a multiple of 10. Then I would want to add 690, and I would need that to be less than, not less than or equal, to 1331. And it's definitely not, which means 10's not going to cut it. But we can look at what we learned from that and build to find the more appropriate algebraic techniques or solution. So more on that in a second. This is kind of where you have your branch off moment, right? Your stronger student, the one that's more trained, is going to be able to recognize what we just did and create an equation out of it. The weaker student might not see it, but there's a difference between weaker student who doesn't see it and gives up and the weaker student who doesn't see it and gets it right out of sheer willpower. That is brute force. You will not give up. You will get it correct. I don't care how long it takes me. I'm going to figure it out. Right? That right there is a very important characteristic and trait, not just for any test, but for life itself. So the next thing up is, if this isn't quite close, right? We saw when we added 690, we're way above it. Let's just take a big jump, right? We're going to continue with the brute force path for now. If I jump to 20 cubed, right, this is 8,000. And 21 cubed, well, that's going to be 441 times 21. And 441 times 21, you're going to get 441, a 0, and then 882. And you're going to add this up. 1, 6, 12, 1, 9261. Now the question is, from 8,000, right, if I add, okay, it has to be, we're basically saying that k would be 20 right now, if you haven't gotten lost, because this would be k cubed that we're cube rooting, right? And so we want to know, can I fit 69 more multiples of 20 before I get to this number? Well, let's check. 2 times 69 is 138. It's 1,380 more than 8,000, but this is only 1261. It's closer, better, this one was like more than 300 above, but we're still not quite there yet. So this, unfortunately, what would happen is if you went to like this number up here, you would fall back to 21, unfortunately. So what I mean by that is if you took 9,380, which is the 69th multiple of 20 after 8,000, and you cube rooted that, it would be 21 point something. We don't really care what the something is because we're rounding down to 21, but we can't have that. It needs to round down to 20. So you can see how this dynamic is playing out, but we sense that we're close. So the next thing to do would be, and again, with the branch off point, we've already passed it. So we'll go back to that branch off point in a second and continue with how we should have gone. But this is done in case you don't perceive that path. Okay, so let's go a little bit higher. Let's do something like 23 cubed, right? And 23 cubed is, 23 squared is 529. Memorize your first 30 squares. Come on. Okay, so 23, 3 times 9, 27, 7, 2, 6 plus 1 is 8, 3 times 5 is 15. But a 0, 2 times 529 is 1,058. You don't have to do it straight up the normal way, right? So 7, 6, 1, 11, 1, 1, 1, 2, 12, 167. Okay, now the question is, if I add from 12, 167 plus 69 more multiples, not of 20 anymore, but we're on 23, will it indeed be less than 24 cubed? Okay, well, let's see. This is 23 times 3, so it's going to be basically 529 times 3, which is going to be 1587. So we will add 1587, 1587 to this, 4, 1, 4, 5, 1, 6, 7, 13, 754. Now, what's 24 cubed? We'll see if we're underneath that. Okay, so 24 cubed is going to be 576 times another 24. So 4 times 6, 24, 4 and 2, 28 and 2 is 30, 0, 3, 4 times 5 is 20, 23, throw a 0, 2 times 5, 76 is 1,000, plus 140, plus 12, 1152. And we add that up, 4, 2, 8, 3, 1. So 13, 8, 24, this is 24 cubed, and since this is lower than it, when I cube root this number and round it down, it will go back to 23. So right now we're aware that 23 is possible, but we have a problem. What's the problem? Well, this is 69 multiples of 23 after 23 cubed. If I add 23 again, we get more than 70 multiples of 23 between 23 cubed and the end. So actually 23 is not going to work, which means it must have been something either 21 or 22. So then you can check 22 cubed. I'm not going to do it because we see how this is working. 22 cubed is going to end up working. You're going to get exactly your 70 multiples. So that's fine if you do it that way. Okay, let's go to the branch off point now that we talked about, which we should have observed, right? And it's okay to be at one level and kind of be working your way up to be able to do things at a higher level, right? So if you notice from early on, we were assuming that this was k cubed and then cube rooting, kind of logical. So let's continue with that. I would need k cubed plus 69 multiples of k to be strictly less than k plus 1 cubed. And this is the important part, because I cannot have more than 70 multiples of k. Don't forget, k cubed is the first multiple. The second one is k cubed plus 1k, right? So you look at it this way. N sub 2 would be k cubed plus k, 1k. And n sub 3 we're saying is k cubed plus 2k. You'll notice that the coefficient is 1 less than the subscript. That's why this represents n sub 70. And we need it to be less than, it can't be equal to. Again, if it's equal to, then when it rounds down, it will come out to be k plus 1, which is not what we want. But in addition, we need this to be less than or equal to, what would it be? Less than or equal to, k cubed plus 70k. K cubed plus 70k. In other words, if I added one more k to this, I need to leapfrog over the k plus 1 cubed. Why? If it was the other way around, there would be, again, more than 70 multiples of k. That was the problem we had precisely with 23 cubed. Yes, it fits. There are at least 70, but in fact there's too many because this says exactly 70 multiples. So this is what we're solving. You should be able to expand this in your head by now. If you haven't, let's improve our skills. Okay, so 69k less than k cubed plus 3k squared plus 3k plus 1, and that is less than or equal to k cubed plus 70k. Again, this is because this would be the 71st multiple of k between k cubed and there, right? So now we will cancel out the k cubes, and you will have 69k is less than 3k squared plus 3k plus 1 less than or equal to 70k. All right, next up, I think we'll just divide by k. And we can do that because we know k is a positive number. And so you will get 69 is less than 3k plus 3 plus 1 over k less than or equal to 70. Okay, let's move this 3 out of the way now. It's going to say 66 is less than 3k plus 1 over k less than or equal to 67. I think you can probably see right now that, if I put 22 in here, obviously I'm adding some positive fraction. It will definitely be bigger than 66, but it will also be less than or equal to 67. So then, this would be k equals 22, whereas if you tried 23 in the k, it would actually go over the 67 and violate the rule that we've set for ourselves. So if you wanted to, you could also divide by 3 right now. You would get 22 less than k plus 1 over 3k less than or equal to 22 and 1/3. And again, it's pretty clear that k would be 22 once again. Okay, so what we're saying then that is if k is 22, obviously n sub 1 would be 22 cubed. Let's go to the end of the problem and figure out what the answer is going to be. That would be find the maximum value of n sub I over k for I in those range. Well, obviously, k is not changing its value. We know that it's 22, but we do want, what we want for n sub I? The biggest one, right? The last one before it would cross over. That's going to be, we could also write it this way. K cubed plus 69k, that's what n sub 70 equals, right? And then we're going to divide that by k. The k will cancel, leave you a squared and a k. So you want k squared, and since k is 22, that's 484 plus 69, 9 plus 4, 3, 1, 4, 5, 1, 5, 53. This is the answer, okay? Now, whether you caught on to the game in the middle and you got it with a more kind of mathematical solution, You've seen that meme, right, where it's got the brain and it's like they're slightly enlightened, and then they see something the next one and they're even more enlightened, and then the last one it's like the brain's like, you know, rays are coming out of it. This is like the ultimate enlightenment, right? That's kind of what this is like, right? The brute force is like, okay, you got it right. The second level would be brute force modified to get to this point. And the most elite level, which you are trying to attain over time, don't worry if you're not there, right? It's a journey to get there. It would be so much more ideal if we could perceive this, you know, right from the get-go, or pretty close to it. But don't worry, right? Even when I did it, I had to do some of this in the beginning, and I used it to branch off to this, right? As you gain an experience, you will see things like this faster, at a faster rate. But don't be afraid to explore, and don't you dare talk down to yourself because you did something like this in the beginning. Even if you finished it with pure brute force, never saw the branch off, never saw this, hold your head high. You're going to win in life, okay? It's not always going to be easy. You might not know the best way, but by golly, you figured it out. That's going to get you qualified for USAMO at some point, hopefully. Okay, that's about it for this question. I hope you guys enjoyed. Have a good night.